All right, hello everyone. So this is just a video going over the practice problems that we did in class for Unit 10. Um, I think these are really good, helpful questions on not only just how do you do the process, but also how can you make your life easier when it comes to test day. So we're going to go through these 5 questions here. Some of them are pretty straightforward. Some of them require a little bit of work. So I got the whiteboard behind this screen here. We'll mess with that here in a little bit. Our first question here involves an environmental agency wanting to estimate the mean amount of lead in the soil of a city park. So they take a random sample of 14 soil specimens and find a mean lead concentration of 115 with a sample standard deviation of 18. And what we're asked to do is construct and interpret a 95% confidence interval for the mean lead concentration in the park. And then we're going to talk about this what if I want to investigate. So let's first deal though with the first question here of construct and interpret a 95% confidence interval. So we know automatically there that's our 4C method. So we're going to start with our choose. What do we care about here? Well, it's a one sample and it's a T interval because of the fact that it's talking about sample means. And then for our population mu, and mu here is just our true mean, not value. Let's see. Our true mean, where's my eraser? True mean amount of lead in the soil. Cool. And then we need our confidence level. We are looking at a 95% confidence level. Cool. So now we need to do our checks. So we have 3 things here. Our first one is random. Was this a random sample? Yes. And we can just state that by took a random sample. Why do we care about that? So we can generalize to the population. Okay, so it's our first one. Our second one, do we pass that 10% so that we can have independence? I think we can clearly see that our sample size of 14 is definitely going to be less than 10% of all um, soil specimens. We could take a lot of different soil specimens. And why do we care about that? We care about that so we can sample without replacement. All right, let's go to our third check we have to do. And this is our large sample. Now, unfortunately here, if you're thinking about the central limit theorem, we don't actually pass this because 14 is not greater than 30. Now, the problem should state, and we're going to say that it does state here. I'm making this video before you guys do this. The question will state it when you guys actually work on it. But we're going to state that the population is approximately normal. And we care about this because our sampling distribution, we want that to be approximately normal. So we need x bar to be approximately normal. And we get through it on this one because our population is approximately normal. All right, so we've done that. So our checks are good. We can now go on and calculate. Okay. Because this is a confidence interval, again, it's not necessary to do the general form, our point estimate plus or minus our margin of error, but we do need to include the fact that it's x bar plus or minus t star times our standard deviation over our sample size, not all in the square root. Only n is inside the square root. Now, I genuinely believe it is helpful here just to go ahead and fill in this information that we have. 18 over 14. We can get our t star a couple different ways. We can use our degree of freedom here. And let's talk about the different ways you can get that. So one of the ways that you can definitely get this is by using your table B here. I'm going to throw this. Let's see if I can bring it up. Using table B, let's put this up here. So you can see our table B here. We need our degrees of freedom. Now, our degrees of freedom is 14 minus 1, which is 13. And then we can just go here. Okay, we have degrees of freedom of 13. And we need to go to the 95% confidence interval, which is right there at 2.160. So this is our confidence interval. You would calculate this on your own, or what you can do, using Desmos, we can go to inference, t-test. We don't have a list of data, but we do have our stats. So our stats are going to tell us a sample size of 14. Our mean was 115, and we had a standard deviation of 18. We insert degrees of freedom down here for 13. Confidence interval at 95% is going to give us a confidence interval between 104.6 and 125.4. Okay, and then the last thing we just have to do is we just have to conclude. We are 95% confident the interval from 104.6 to 125.4 captures the true mean amount of lead in the soil. So I'm going to zoom out just for a minute. We see, yes, there is a decent amount of work involved in order to do question 1. And this is just the first part because we also have part 2 of that. And we'll go back and look. Part 2 asks us, I want to investigate if it's unusual for one area of the park to record a lead concentration of 80. Is it appropriate to use the confidence interval to conduct the investigation? What do confidence intervals tell us? They just tell us the interval that we believe captures the true mean amount of lead in the soil. We can't really do any investigations here. So what we should say is no, it's not appropriate. But the question becomes why? And I think the easiest way to explain why, like if this were an AP test question, what do you say here? I would just explain what a confidence interval is or what it provides. It provides an estimate of the population mean. But it does not provide information about the range of individual values. While we can claim that something like 80 is not within our confidence interval, what that is telling us is that the true mean we don't believe is 80. That doesn't mean anything about a specific area. It doesn't tell us if for one area. It tells us the mean in this case. So our confidence interval does not provide an appropriate way to conduct this investigation. It only tells us or provides us with that estimate of the true mean. I think that's a way to answer these type of questions. AP loves to give these, so be aware of that. Okay, some of these we're going to do. I don't think question 2 and 3 will need much work on. Question 2, let's just take this here for a minute. So, a study was conducted to estimate the mean weight of adult grizzly bears. Based on a sample of 40 bears, that should say bears, let's fix that. The researcher calculated a 95% confidence interval of 420 to 480 pounds. Which of the following would result in a narrower interval than the one provided? Increasing the confidence level to 99%, decreasing the sample size to 20 bears, increasing the sample size to 100 bears, or increasing the standard deviation of the sample. Hopefully, one of the things you've learned in AP Stats throughout this year, if there's been anything, as n increases, your variability will decrease, right? The correct answer here is C. If we increase the sample size, we're going to see our confidence interval become narrower. So should be C there. Okay, question 3. A 98% confidence interval for the mean number of hours of student sleep is 6.2 to 7.4 hours. Which of the following is a correct interpretation of the 95% confidence level? Remember with this here, you have two different things. We don't ever interpret the confidence level in when we construct the interval. But we want to talk about what does that 98% confidence tell us. So what you want to think, what does 98% confident mean? That's our question to us. And when we're thinking this, what we're talking about when we're 98% confident, we're talking about the fact if we constructed a lot of different confidence intervals, 98% of them would capture. And here we can see A says there's a 98% probability of the true means between that. Confidence intervals, confidence levels, they do not tell us, because we're 98% confident, that doesn't mean we're 98% confident somewhere in here. 98% of students in the population sleep between this. Again, that's not what we're saying here. We're not saying that 98% of our population is within here. C, in repeated sampling, approximately 98% of the intervals constructed will capture the true population mean sleep time. Again, that's what we're thinking here. Think back to, I provided this a long time ago with different confidence levels or intervals that we create. And if our true mean is somewhere here, what we're trying to say is that we want to ensure how many of those intervals are capturing the true mean. 98% confident means that we believe that 98% of the intervals constructed will capture the true population mean of whatever. So that's the correct answer. Notice that it's different than what we talked about specifically in our notes back from Unit 8. It's not the exact same wording. It's very similar, but it's not the exact same, and that's okay. Find the best answer here. We are 98% confident that true mean sleep time for students is this. That's like beginning to do the conclusion, but then it just kind of doesn't do very well for us. So correct answer here is C. All right, question 4. A teacher or a researcher wants to know if there's a difference in the mean reaction time between students who drink caffeine and those who do not. So we get some information for group 1 and group 2. Construct and interpret a 95% confidence interval for the difference in mean reaction time. And we're told caffeine minus none. That's important here when we start labeling things. So let's go through. So question 4. All right, choose. This is a 2-sample T interval for mean 1 minus mean 2. What are those represented with? It's the true difference in mean reaction time for students who drink caffeine and students who do not. And we're going to say caffeine minus none. That way we get the direction 100% right for everyone. Our confidence level, 95%. Okay, checks. So, first one, were we random? Researcher wants to know if there's a difference in mean reaction time between students who drink and those who do not. You know what? Again, another small error here. The researcher takes independent random samples. Let's just add that in there. And just for fun, let's change this. Let's go 30 and 32. Let's go there. Okay. So slightly had to change things. That's okay, though. So, yes, there were independent random samples. And we care about that so we can generalize to the population. Okay. Next, 10%. Remember, we have to check these for both populations here. So our first one, 30, that's less than 10% of all students. And 32 is also less than 10% of all students. Why? So we can sample without replacement. All right, and then finally, third, large samples. So we have to check this for both. By the central limit theorem, and I actually think, even though I was about to do it, it's best to spell this out. By the central limit theorem, 30 is greater than or equal to 30, and 32 is greater than or equal to 30. So, the sampling distribution of x bar 1 minus x bar 2 is approximately normal. Don't forget, when we have these differences, we have to make sure that we are checking both 10% large samples for both populations. Okay, so we have those. Now let's move on to calculate. All right, calculate here our formula x bar 1 minus x bar 2 plus or minus t star, and then times s1 over n1, s1 is squared, plus s2 squared over n2. Again, I think it's a really great idea to go ahead and fill in your formulas here. And we'll come back to t star. We'll deal with that in a second. So fill this in here with our information provided. Let's look at t star here. So you have a couple options. Remember, for your degree of freedom, you can, 1, use Desmos, or 2, use the smaller degree of freedom. So I'm going to use Desmos this time. We could check it here because our smallest sample size is 30. Degree of freedom is 29 for a 95% confidence interval. We're looking at 2.045. Let's see what Desmos says, though. Inference, t-test. Again, we have the statistics here. So a sample size of 30, a mean of 0.45, standard deviation of 0.08. Don't forget we have a second sample. It is important to Desmos. Sample 1 is your first one. Sample 2 is your second one. You do want to make sure you have it going in the correct way here. Make sure you also put things in the correct spots. So, create test. So, and then again, we're not doing significance test, but under significance test, we can use that degree of freedom. So we're going to state that our degree of freedom here, we can either use Desmos. If we use Desmos, we get a degree of freedom of 56.59. We can also just use our smaller degree of freedom. Let's just use that, fill it in. It's not going to make that big of a difference here. Because we can even see we would just end up using 50 here. So we can just put in 2.009, call it a day. I guarantee this result is going to be very close to what Desmos uses here. Desmos is going to tell us for a 95% confidence interval that the interval is negative 0.119 to negative 0.021. All right, conclude. We are 95% confident the interval from negative 0.119 to negative 0.021 captures the true difference in reaction time between students who do drink caffeine and those who don't. Cool, so we did all that. Again, I like to zoom out just so you can see. Decent amount of work involved here. Nothing you can't handle, though. Let's look at that second part, though. Again, this would be slightly different. This Desmos interval will be slightly different than if you calculated this by hand. It is okay to use a range here. Obviously, 56 was not on our degree of freedom table here. That's okay. 2.009. Either way works. I think what's really important here, like filling in this information here, lets whoever's grading this know what values you used here. That way they can understand your confidence interval. One thing you can think without doing too much work here, I don't want to write it out. If you flipped and did the no caffeine minus the caffeine, this interval is going to flip. because we're going to see our x bars flip and go opposite. So now we're going to have positives. But it is important for them, the grader, to see which way you went with everything. So just be aware of that. Our second question said, based on the interval, is there a statistically significant difference between the two groups? Yes, because the interval is entirely negative. This shows the students who do not drink caffeine have a different reaction time than those who do. Hopefully that's obvious here because our interval is entirely negative. Okay, last question here. Let's look at question 5. Probably going to be another constructing. Let's go ahead and look at it. All right. Does a new memory boost supplement actually work? A study recruits 10 volunteers and gives them a memory test. 1 week later, the same volunteers take a similar test after taking the supplement for 7 days. The scores, which is done via our number of words remembered, are recorded below. So you see this table, you have the volunteer number, you have the before score, the after score, and then you have the difference. So let's talk through this here, because what are we going to be asked to do? Construct a 95% confidence interval, and then it tells you use the mean standard deviation. And then based on the interval, is there evidence that the supplement improves memory? So one thing we see here, these are the same people. They're getting a treatment of the before and then after taking the pill. That's what we're measuring here. So everyone is taking both versions. And we can see here, this is kind of where we get into this like match pairs idea. We're looking for a mean difference, right? Not a difference of means, but a mean difference. So we're still going to construct an interval. So now we're on our choose. And now there's a couple ways you can go about it. You can check your notes. I'm going to call this a one sample T interval for mean difference. What is mean difference? It's the true mean difference in score before minus after. Actually, we'll do after minus before just for fun. Okay, and then our confidence level. We are looking at a 95%. All right, our checks. So, oh, that disappeared on me. Was it random? Yes, random sample of 10 volunteers. Sure, and we can look back at the question here. Study recruits 10 volunteers to give them a memory test. For the purposes of this, we're going to claim that they were a random sample of volunteers, that we had thousands of volunteers and we randomly selected 10. That way we can actually do the problem. And we want to generalize. Okay. 10%. Yes, 10 is definitely less than 10% of all adults. We'll claim these are adults here. So we can sample without replacement. Okay, 3 here. So let's look at this large sample. What we can see here when we start looking at our differences here, we can see here that there's no strong skew. We have kind of everything all over the place. We have some greater than 3, greater than 2, 0, greater than 4, -1, 1, 3, 2. We don't really have any strong skew here. So what we can say is the distribution of differences has no strong skew or outliers. And so the sampling distribution of our X difference bar is approximately normal. All right, so now that means we're done with our checks. Let's now calculate. Again, we're going to do X bar difference plus or minus our T star, and then with our standard deviation difference over our sample size. Here we can see, if we go to the next one, we're going to use a mean of 1.9. So let's fill in 1.9 plus or minus. We'll come back to T star. Standard deviation of 1.45 over our sample size of 10. We can use our degree of freedom here to be 9. So we can always use our table for a 95% confidence interval, 2.262. Now, we can also just plug in on Desmos here. We have sample size of 10. Our mean is 1.9, and our standard deviation is 1.45. We can see here degree of freedom 9. Significance test at 95%. We are going to get 0.863 to 2.937. So then we're going to conclude. Oh, hello. Okay. Sure. Okay, conclude. We are 95% confident the interval from 0.863 to 2.937 captures the true mean difference in score on the memory test. And then after minus before. Okay, so we have that. We're almost finished here. Now we just got to answer our question. Is there evidence that the supplement improves memory? Yes. The interval is entirely positive. So there is evidence the supplement improves memory. All right, guys, that's it. I know that's been a long one, but hopefully you take some things away from that and can use this to effectively help you study for your AP exam. So good luck.